Hey everyone, welcome to our sixth installment of our series for webinar. Hoping all guys are doing good, especially since phase 2 has started. I think a lot of people I've seen a lot of people going out and about. How about you, Horizon? Have you been enjoying the fruits of our, I guess, labor in a sense? Like after a few months of circuit breaker, now we are sort of enjoying time outside as well.
Yeah, I mean, maybe I'm enjoying a bit too much, like, maybe we're getting this teh tarik like almost every other day. It's like, yeah, finally, a chance to eat out, a chance to like grab a drinks and everything. But I think like nowadays, out there is actually getting more and more crowded. It's election season, right? I mean, so I guess that's probably why.
Oh,
Like,
yes.
Yeah, I mean, like, there's a whole bunch of people walking around, I suppose. I mean, not in my area. I mean, for me, my focus is just on the food. Like, everyone else is the distraction there.
it's so election is, since you're talking about election week, election, the day itself is 1 week away, right? That's 10th of July.
Correct. It's next Friday, if I'm not wrong. So
Right.
it's going to be like interesting. Interesting is not because of the political party or whatever. It's more interesting where for now, for the first time, you see everything being moved, like a whole bunch of the activities actually is being done or moved online. So I guess the first time you see a lot of people, a lot more online activity, and then I guess it's kind of, I guess it's interesting to see how it goes. I mean, with all these activities being done online, but I think let's not like touch to the topic of how each party will perform whatsoever. It's like this channel
It's
is
a
totally
politic
not,
thing.
yeah, it's totally not that. We'll be focusing on technical content, and that is, I guess, that's more interesting as compared to all this like political stuff. All
But it's
right.
interesting now to see that I started hearing like, the lorries that go around your estates and they'll start, they have the loudspeaker and then they'll start saying, vote for whatever party. Yeah,
Yeah,
I'm
I actually
starting to do it now.
yeah, I actually half expected like them sending drones around already by now,
Oh,
but
wow, yeah.
okay, like maybe it's a good thing that they are not like deploying drones and like blaring the announcements right in like everyone's faces from even when you're high rise, right? Imagine the drone flying right outside the window and it's like, oh, vote for some party or whatever. That would be a pretty scary world, I suppose.
But there will be also massive breach of privacy.
Yeah,
Yeah.
or not, yeah.
But actually, there are startups that are around that area of using drones to deliver products. Wonder how they'll get around that issue of this privacy issue, because they have to deliver these items using the drones into estates as well. I think I've seen one of these startups in NUS, which they're trying to do something like that.
Yeah, but
Okay.
I guess it's a pretty complicated issue. Yeah, it's more on the IoT side of things. Like there's beyond the privacy issue. Privacy is one thing. I mean, the one of the main issues is energy. Like drones don't have long flight times, but yeah, like our rocket here, like it's about to fly, but don't know how long it will fly. This rocket. All right, I
Okay.
guess we should get started.
Yep. So let's get started with today's webinar's content. As always, we have our nifty human RSS. And as always, if you have any feedback, do let us know in regards to the content we have here. Or if you have things that you want to share with us, do write into us and let us know as well. Let's get started with the first segment that we name as the shiny new stuff in GCP. So shiny new stuff. One thing that I'm very excited to discuss about, like I saw this earlier this week and I immediately told this to my colleagues. And I think the first reaction they say is, let's use this, let's get a discount right away. Because the idea is that if you're building applications in GCP, if you have databases, if you're using Cloud SQL, usually you would want to have that even with this managed database, you want to use it for extended period of time. You're not going to be looking at using migrating into another cloud provider or moving to self managed database. So having something like this, a continuous use discount for a longer period, when you use your Cloud SQL, be it MySQL, Postgres, or SQL Server, as long as you use it for extended period of time, you can actually write in and say, I want to commit my usage for this period of time and get a discount for that. So this was released somewhere, I think mid of last week or early last week. You can see over here. So it was. It's not just for, as I mentioned, it's not just for one single SQL, but for MySQL, Postgres, and SQL Server. And it's quite exciting. Let me see if I can show. Yeah. So basically over here, this is for like what they have put in documentation, which is that if you commit to 1 single year worth of usage, you get 25% discount. Commit for 3 years, you get 52% discount. This is not inclusive of future changes in prices, based on the TOC that I've read. And they also mentioned the percentage is same across every single region. So this is pretty awesome, especially, I mean, 1 year, but 3 years is a bit long, but I would think that 1 year, it's still kind of okay. Like, maybe within 1 year, you might have to look at moving your workloads elsewhere. But I mean, within this 1 single year, you could get this discount for just 25% as long as you can commit to it for 1 year. So yeah, this is pretty awesome. You can go to this link over here, bit.ly GDG, okay, actually it's GDG6 PGSQL. So you can search out on this. You should be able to get to see that the release notes on this. Okay, so another thing that we want to share that I'm also very excited to share about because I love Cloud Build to my core. So for myself, when I built my tools with Cloud Build before, I think one of the things that we talked about within our teams is notifications, because Cloud Build runs on a different system in GCP. And what if the Cloud Build has finished? How do we notify our teams, our individual engineers that the build has finished? How do we let them know that they can now, perhaps they can finish the entire CI/CD pipeline where the CD is referring to delivery, and the engineer has to step in and trigger the action to do the deployment. So the release notes, as you can see over here, they are now supporting open source notifiers for Slack and SMTP, which is essentially for emails. And you can also look at the documentation over here. Yeah, I mean, so in addition to the current HTTP, which I believe that's referring to sort of like a webhooks that you can call, you can also, use this to notify as seen here, over here. So if you're interested, you can check it out over here, GDG6 Cloud Build. I think this one will show you documentation for this.
I do think it's kind of interesting where they are like allowing users to like send these notifications to like Slack, but not Google Hangouts. Like I thought Google Hangouts would be the first target before Slack. But yeah, it's a pretty interesting approach, I suppose. I mean, maybe they do recognize that actually, like among the users out there, like Slack is actually way big, has a way bigger user base as compared to Hangouts. Or like, what is it called right now? I'm not sure, man. The name of the tool keep changing.
Yeah, I guess maybe it's more targeted towards enterprise in a way that like more companies use Slack as an enterprise solution for communication. So it makes sense that like a lot of companies would have already integrated chat ops into their Slack what do you call it, their Slack workspace, and this will built into part of those chat ops. Yeah, actually that's a very interesting point. But I think maybe the other part is also that like have you heard about like Google Hangouts being used for chat ops? Because I also never heard about that before. So yeah, the thought never came to my mind. Maybe that's why. Yeah, I think it's used more as like a chatting application. Maybe something more along the lines of like WhatsApp. So not so much on the end of enterprise, I guess. Okay. Okay. Maybe let's move on to the next one. So this one I would say is something that probably most of us won't really get to touch, but it's still interesting to discuss about it because we talked about, I think a few webinars ago, we talked about Anthos finally being able to serve, using Anthos service mesh, being able to serve Kubernetes clusters deployed in other cloud providers, namely Anthos with AWS. And this is very interesting because based on the documentation notes, it seems like this will be able to support multi-cluster configurations and management via the service mesh. So this could mean, like, I think right now, like before AWS was actually supported, we had the configuration of clusters locally towards within GCP. This could be hinting towards more of a direction where you can have, now you could have be able to manage multiple Kubernetes clusters within your own projects. This could actually pave the way towards, if this is not in fact referring to that, but it could also pave the way towards being able to manage multiple clusters across not just GCP, but also other providers like AWS. So it'll be interesting to see developments in this area. Yeah, and I just put like a short definition. So over here, because I think before this, I was also not very sure regarding a definition of multi-cluster meshes. But yeah, just to mention is mainly this update is just letting us know that it's to allow for multiple Kubernetes clusters to be able to have their services have communication within each clusters. So let's say if you have different clusters with different purposes, they could basically communicate across these different clusters instead of housing every single service within one cluster. So if you end up having multiple clusters set up within GCP or maybe within a local, maybe you have your on-prem clusters together with GCP, I think this is something that you can look towards using. So yeah, right now as seen over here is actually, they're saying over here, Anthos Service Mesh supports multi-cluster meshes, but it's in beta, so take note that it's in beta. But it's an interesting aspect that they have, or rather, it's an interesting news that they have released something that you can look towards using if you are using Anthos and you have multiple clusters, you are looking into managing them together. Okay, so miscellaneous BigQuery updates. Very interesting. I would say two things. Let's look at the first one, which is, okay, over here, they've mentioned over here, flex slots are generally available. We'll talk about that a bit later. But the second point over here, BigQuery SLA has been updated to 4 nines. And yeah, you can see over here, so I've mentioned here 4 nines, monthly uptime percentage for all users. This is just to give a bit of perspective from what they updated last year. September 17, 2019, when they last modified the documentation where they only guarantee you 3 nines. So it's kind of interesting now that they must have done some update behind the scenes that now is more reliable. They can actually guarantee 4 nines. 4 nines is actually quite a huge milestone, right? Like from what I remember, if you have 4 nines, I think it's something along the lines of like seconds of downtime in 1 month, if I'm not wrong, less than 1 minute. Do you recall anything like that?
I mean,
seconds, yeah.
Probably need to go and do that calculation. I would expect it to be in the minutes or even
Minutes,
seconds. Yeah, but then imagine that like the downtime is seconds with such a complex system with BigQuery. And so BigQuery is like you send the query and then the query is being worked by multiple machines, right? So that means the fault tolerance aspect of it, like probably a lot of it has been improved. But then again, like BigQuery is a pretty old product. So I guess now they are trying to appeal to the enterprise users like, hey, look, this BigQuery product is really, really reliable. And you can expect it to be up when you need it to be up. Because like 99.9, I think still, I guess for some people maybe is a turn off. But then again, like you know, looking at the capabilities of it, it's pretty wild. Being able to process like petabytes of data quite easily, and then now with 99.99, so it's 4 nines of reliability. So yeah, it's kind of mad.
It's interesting you mentioned about the petabyte. So I think later we'll also be talking about something like that, right? It's kind of peering the power of BigQuery, like not just being able to use it as it is. You can also interface it with things like Googlesheets. I think that DataStudio as well. Different products in the entire ecosystem, like not just within GCP, can be used together with BigQuery. I think that's the kind of the power as well as maybe the the extensibility that they have built in with BigQuery over the years. It's quite interesting. In fact, I was watching web.dev, so that's more on the web end of things for Google, where they have this this online seminar for 3 days now. So today is the last day. 2 days ago, in fact, someone actually showed like they did a presentation on using BigQuery for going through Chrome performance metrics. So for websites, which was really interesting to see that BigQuery can even cross to that extent of like not just being able to use for your different enterprise products or your different applications that you're trying to build, but also for performance assessment. Yeah, that was really interesting to see. Okay, anyway, I don't talk about that too much, but let's just go into the flex slots that I mentioned just now. So flex slots was something that came out I believe earlier this year. I saw documentation, I think it's something like February, might be wrong. But yeah, basically just to explain about flex slots. So just now I mentioned flex slots is going to GA, but from what I was able to capture from a different blog post, I think the explanation about it is basically if you look at most products, even within GCP, the pricing usually is more attuned to the level of like monthly payments or annual payments. Like just now when we discussed about the commit use discount for SQL, those are by annual or by 3-year cycles. So BigQuery is no stranger to that. Like within the pricing list I saw just now, it's by monthly or by annual. But flex slots provide a different perspective to that, giving you like each slot, from what I understand, it's like you can see over here, up to 60 seconds, and you purchase the slots that you need. So it's really interesting because if you just need to use this product for a limited amount of time, you can look at using it, for just purchase the flex slots for you to just use within that time. For example, maybe let's say if you have a cron job that runs, and maybe it happens that you just need to use BigQuery, every Monday every Monday maybe just for 8 a.m. to 8:30 a.m. So you could just use this flex slots to help you tide over this short period instead of, let's say, getting the monthly expenditure on using this product. So Harrison, do you have anything regarding flex slots?
Yeah, I guess like for those who are kind of confused what this slot stuff is all about, because these slots, I mean, when you use BigQuery, right, you don't exactly think about how much resources you need or whatever. All you do is just plug in the data and like, you write in your query and then magic kind of happens after that, right? So this slots thing, like behind the scenes, actually, you are actually taking this like resources, like they call it slots. I'm not sure what's the actual definition of what a slot really is, but the way someone like kind of informed me, it sounds like a computation unit that BigQuery kind of uses. So that is how that is kind of how like Google controls how much BigQuery you can use. So there is so by default, I think there is a certain limit for each okay, let's say if you get a GCP account for the first time, right? There is actually a certain amount of limit of slots that you are entitled to. So if you try to query too much, the BigQuery, like on BigQuery will actually tell you, hey, you don't have enough computation to do this query. Like maybe you need to look into these flex slots, into the like purchasing more slots in order to run this query. So I do remember previously when I worked, there was instances where like people run a lot of queries and in a certain time period, and then they kind of ran out of slots, and then they can't run any more queries for the next hour or some sort. So they had to kind of like save up their quota and then run queries like after 1 hour or something. So it's kind of nice that you see this flex slots capability. I think like on the enterprise level, like this, I guess, is a feature that is kind of desired by most, like being able to just purchase a small subset of it. Because in previously, like you had to purchase like huge bundles of these slots, and they cost a bomb, if I remember correctly. Yeah, but then again, I guess the details of this is all available on the website, the costing, the pricing, and everything. So yeah.
Okay, let's move on to the next part. So last webinar, we talked about Jakarta. So we mentioned about the release of that region, but it's actually not true. It's not really a release of a region. It's been there for quite a while, but it's just more of that. A lot of different GCP related tools were being released in that region. So given that we are all in the Southeast Asia region, it's really exciting to see that now we don't only have just like one single region with zones only in Singapore. Now we also have a separate choice that we can look as maybe sort of as a fallback. If you have applications where you have to run within this region, you want to have that additional, like maybe your failover clusters, you can set it within the Asia Southeast 2 region. And you can look towards like Jakarta's the range of the products within that region. Essentially, I think within the last 2 to 3 weeks, they have released a lot of different things there, including things like cloud storage, being able to use it within that cluster, rather this region as well. So yeah, okay, let's move on to the next part. So, spreadsheets on steroids. This one is very interesting. I think Harrison alluded to a bit of this earlier on. And if you look at the link itself, essentially is pointed to this article, which is talking about Google Sheets interfacing with BigQuery. So petabytes of data powered by BigQuery. And I think the product itself is called Connected Sheets, right, Harizwan?
Yeah. This, I mean, how do we say this? Like, okay, so well, the one that usually the people that usually analyze data are usually like data analysts, and then data
Yeah.
analysts, they actually they really like spreadsheets a lot. So one of the first things that they do, right, is like they come to the thing, they started use spreadsheets. Then one of the when they need the data, right, the data is usually maybe in BigQuery or some SQL or something. So the data sometimes needs to be imported into spreadsheets. But and then they can do like their further analysis, like make charts of it or something along that line. But the thing is, there is a limited amount of data that can be pumped into spreadsheet. Like imagine that you can't get like gigabytes of data and put it into a spreadsheet. There's no way for that to work. Like you can't. I imagine you can't do that on Excel either, right?
Yeah,
So
definitely not.
like there is that threshold for spreadsheets. Then beyond that limit, like things start to break down. So so this like if you read this article, the link down there, they they provide kind of the capability for these data analyst users who need to analyze huge data, right? To rely on BigQuery to do the analysis. So like you are like for the data analyst, he's interfacing with the spreadsheet, but then behind the scenes is actually BigQuery. Yep.
Okay. So anyway, so yeah, check out the this link over here. It's quite interesting. It's an interesting read. I just read it up on this as well. And yeah, it's quite interesting to see how Google Sheets has developed over the years, being able to interface with things like BigQuery. Okay, let's move on to the next one. So bare metal. Bare metal solution. Okay, so I just want to emphasize that bare metal solution here, we're not referring to it as like this is a bare metal solution, but there's actually a product, a tool on GCP called bare metal solution. So essentially the understanding here is you're not just looking at virtual machine really, you're looking at taking the V away from a virtual machine, like no more virtualization, it's back to the machine. It's a very interesting, instead of upward direction, now you're going back downwards, but it's more catered towards companies who needs the control at that low level as well. So they just need the hardware, the hardware itself to be provided by Google, the initial DevOps setup, things like the firewalls, things like the network being set up by Google, and then they want that virtual machine, not virtual machine again, not virtual machine, but the actual machine itself. But of course, this comes with a lot of prices with things like security. You need to take care of things like the updates, OS updates by yourself. So, Harzan, do you want to add more to this?
Yeah. Like, I mean, okay, for most workloads out there, right? I mean, you don't exactly need this bare metal capabilities. Like, just putting them to VM or into containers is good enough. So in certain cases, like in the case of the links that we provided here, right? The reason for this requirement to have this bare metal capability is less to do with the technical bit. I mean, there are some cases where the technical reasons is that are definitely valid, but for some of the cases, it's actually more of a licensing issue or more like business reason. So because of business, that's why this solution is kind of required. So I think one of the main things is trying to get Oracle DB to run. So there is a certain limitations to on the licensing for Oracle DB, like they are particular about what kind of hypervisor to run on so that they can compute out number of cores that you are technically purchasing from Oracle. So like I'm not exactly too sure about the details of it, but the if you want to read more on this, there is a pretty decent summary article about this in the GDG 6 Oracle DB article that actually sums up pretty nicely about this whole issue. So I think it's an article by Avinash from Cloud Ace. So yeah, I'm pretty sure they know about this because like they do talk to enterprise customers. Yeah.
So
So
this, go ahead.
yeah, so for more details, read read the articles, I suppose. Because like I guess for both of us, we mainly deal with the top of the stack, more like a VM than container level.
Yeah, VM and above.
VM and
Actually,
above,
yeah.
yeah,
Do you think
very
if it's
nicely.
minus VM, right, you'll be like my own machine already. Like I wouldn't
Yeah,
even look at you going to Google and asking them for their one of their servers. Yeah, I think this one it's a solution that is extreme in a different direction, but needed because of things like you mentioned licensing. It's required because of different business needs, I would say. And I think later we're going to be exploring an article that talks about a solution in a different extreme direction, more on the, not serverless, but more on the orchestration side. We'll talk a bit about that later. Okay, so I would say that's the end of the shiny new stuff. Let's look at tips and tricks. And this one is something that I found. Basically just to mention is 13 most common Google Cloud reference to architectures used. What it essentially means is that the 13 most commonly used patterns of product use in a certain way within Google Cloud. And this was kind of like a sort of a short campaign ran by Google itself, or rather this developer advocate in Google, where she went through like 13 days of short videos on Twitter to show you, how, for example, how to deploy applications within the cloud. So it was a very interesting, sort of not read, but rather view. You can actually go through this 13 very quickly if you want. It's also quite interesting to learn, different Google Cloud architectures, not architectures, but the reference to the workflows and architectures that other people have been using that I also wasn't aware of before. So yeah, you can just look at. So this one is actually the blog pointing to the review of the entire thing. But if you actually go to this, you'll be pointed to you'll see the 13 tweets that she put there, and then you can actually go to her tweets and see the actual video itself. So it's quite interesting. Like for example, you can see over here I put two examples. One is the hybrid architecture, cloud bursting, and another one web hosting, as I mentioned just now, web hosting on Google Cloud. So both of this you can see they're just short videos. So you can take a look at that. Basically, it just teach you the overview of all these different architectures. Okay, so that's the part of tips and tricks. Let's look at community content that we found for this week. And this is what we mentioned just now, another extreme solution in a different direction. But this is more of the craziness in being able to run a Kubernetes not clusters, but cluster with 15,000 nodes. So for those people who run their Kubernetes cluster, for a company or for yourself, you know, what nodes mean. Essentially, those are your virtual machines run within your node pool or your cluster pool, for your clusters. So one clusters can have multiple node pools. One node pool can have multiple nodes. But usually, when we deal with our products, even for I think like let's say products that I've been in charge of, it has a scale past maybe I would say like 20 or 30 nodes. I think the previous limit itself is within Google or GCP itself was 5,000 nodes. And now they raised it to 15,000 nodes. They ran this case study with this company or this organization called Bayer Crop Science. From what I understand, basically, this company was running the analysis on the DNA or genome of the crops they were looking at. So just to see the suitability of these crops towards the yield or something along those lines. So you can see that it's basically a job, like a bunch of jobs that can take a long time to complete, going through the entire DNA structure. And it would make sense for them that they want to have one single cluster with a lot of nodes running all these jobs in parallel. But 15,000 nodes, this is really, really crazy. I've not seen something like this before. Like, I think I was also speaking in Horizon like a bit before this, and we discussed about like basically if you have a master node, you have all these different nodes communicating with the master. Like I wouldn't be able to imagine like that one master node must be doing a lot of things at once. Like how can it even survive under all this pressure?
Yeah, I would just like to remind that open source Kubernetes is kind of like the current max standard is 5,000 nodes. So it's saying this 15,000 is like 3 times more than what open source Kubernetes is supposed to be able to handle. So pretty sure they done a lot of tweaks to make it like somehow work. I do like read some of the articles out there about or like some of the stuff that they need to do in order to like be able to achieve this 5,000, even achieve the 5,000 node mark. But the 15,000, I'm not sure what kind of hybrid Kubernetes they are running. It could be their own like mutated version of it, but who knows? But one thing's for sure, I'm pretty sure they're gonna boast about it on Cloud Next
Cloud
Air.
Next.
I'm not sure which week though, because like there's 9 weeks of content, right? And hopefully it will be on week 1. I think week 1 is
No, this
the
is for
one.
business tools, I think. Week 1.
But I guess we'll see how it goes. But yeah, this is definitely a case study that they will definitely bring up
Yeah.
during next. Definitely on how they are doing it. Hopefully they will like explain on the like what the technical challenges they need to solve in order to do this, because like this 15,000 nodes is kind of no joke here.
Yeah. Imagine the cost that goes behind this as well. This is, I think we were also speaking about it yesterday, and I was also saying that this can't be like, the type of like N1 standard nodes. This is definitely, if they have to go to 15,000, that means they probably have already stretched each of the nodes to the maximum. Like probably is something like N1 high mem 32, like, all those, or I think the max in GCP is 96 cores, right? Imagine this 15,000 96 core machines. Oh, that would be really crazy. I think that's
They'll
a
probably cause
high
a
cost
bomb.
of yeah, that will cost a lot. Okay, anyway,
Yeah.
if you guys are interested, like go read this article. It's a pretty interesting read. Okay, so let's go on. So this one is just more of introduce to you guys. Like we did this talk last week. Horizon and I, we did this talk with Google Developer Space, and the event itself was called In the Cloud Serverless with GCP. We actually did this. We had a Q&A, but we weren't able to answer a lot of those questions. So if you're those who ask some of these questions, you can actually go to this link over here. It's a link to Medium to where we address each of those questions. Yeah. Okay, so let's move on next on our last segment, which is the learning corner. So just to introduce you guys some of the things, tips that we have saw in regards to learning more about GCP. Okay, so well, I think you guys are sick of me saying this, but I'm going to say it again because it's Cloud Next finally is coming. 2 more weeks, yay! And yeah, just to mention, okay, I'm going to go back to the. Oh wait, the link is not here. I'm going to show the link a bit later, but basically, Cloud Next, you can sign up for 9 weeks of content. Oh yeah, so week 1 is industry insights. I think just now we were talking about the 15,000 nodes. Probably will be under infrastructure for week 3, I guess. Week 3, yeah. Anyway, so it'll be 9 weeks of different content. If you find something that is within these 9 weeks that you are interested in, you can definitely look into signing up and checking those different checkbox. They will send you the notification and letting you know the events as it comes near. So each week they will have different events covering the topics as seen over here. So just to flash the link over here, cloudwithgoogle.com/next/SF. All right, so we'll sign up for it July 14th. It's coming soon. Less than 2 weeks already. Yeah. Okay, okay, so this one is kind of related to Cloud Next, but not 100%. Basically, along with Cloud Next, they're going to be organizing a bunch of study jams. The fun thing is that they're going to do it for 9 weeks. So together with each of the 9 weeks of the different topics covered, every single Wednesday. This one is in Singapore time, but they haven't really reviewed the exact date. So July 16 to September 10. So July 16 is a Wednesday, and you will go week on week every single Wednesday until the last of the 9 weeks. So you can sign up for it early. You can go to this link over here, GDG6 Study Jam. Check out the things that they'll be teaching at the time, and what they'll be conducting under this study jam. Okay, and so this one is kind of a callback to, I think, in the last 2 to 3 months since April we've been mentioning. I think in April we mentioned there was this 1 month offer that you can sign up for 30 days free of GCP, and then in May they did it again, and in June they did it again. I think right now this is essentially the same link. Apparently it's still on offer right now. So if you have not yet claimed that 30 days, do go sign up for this. So I just checked the link is still there. So you can just try out and get the 30 days of free of GCP. 33 days for GCP using this link. Okay. Okay, so with that, I think we can move over to our first speaker. Okay, let's see. So
let's invite him in. Let's see.
yes,
Hello, Russell.
Hello, how are you?
Yeah, doing pretty good.
same.
Yep.
Doing good.
All right. So,
Welcome. Yeah.
all right. So I guess me and Wei Yan will leave the stage. We will switch over to your slides. So yeah. Okay, and we'll leave the stage to you. Hold on.
Okay, thank you. Let me share my screen. Okay, can you see my screen?
Yep, you can see your screen.
Hello, can you see my screen?
Yes, we can see your screen. Might be good to go back to the slides.
Yes. Can you hear us?
Yeah, I can hear you. Can you hear me?
Yeah, we can hear you. So we can see your screen as well.
Okay.
So currently, yeah, I think you might want to switch back to your slides because now it's the infinite recursion thing.
Okay, let me share my screen. Okay.
Look
All right.
good.
Okay, thank you. Today is a BigQuery night. So Google BigQuery is the future of analytics as you know that. So let me introduce myself. I'm Rasel Rana, a C2 and as a Scrum Master working as at Latcastle Partners since 2015. In Latcastle Partners is a data-driven consultancy firm. Here I'm working since 2015 as a C2. We work with data. So when we work with data, it's came up how we get the better decision using the data. Right now, we have a consultancy team, data-driven team, data analytics team, as well as data scientist. So we came up a decision why we want move to our session or our data into cloud. So in 2000, end of the 2017, we got almost 160 million data from a largest telco operator in Bangladesh named GP. So when we try to analyze those data, we figure it out that we need more computation power. We need a sustainable system which can be easily manageable and it can be scalable. So then we move to Google BigQuery. So let's next for the BigQuery. Why we use BigQuery? To generate report till now, right now we are using some legacy report in our business analysis till date. As of date, as you can see, as a SME or mid-level or small level organization still are using some legacy reports to analyze their business and customer information as well as IoT devices record are analyzing by legacy report. But if we want to do the advanced level analysis, so we need a system which can be easily scalable and where we can do restarts or lifetime or real time in a second. So that's why BigQuery came up. And the another most important part is BigQuery has been less expensive and it's very, very fast and efficient. So BigQuery supports standard query languages which runs a terabyte data in a second. So that's why we came up on BigQuery solution. Now, maximum organization moving Hadoop or Scala to BigQuery because it's store hundreds of terabytes of data, pay only what you are right now using. So it's one kind of pay as you go. Here you can query billions of record within a seconds, and you can read, write, or some any types of operation within very fast. And it uses SQL syntax, so it's pretty good for all of us as a developer. You can your SQL queries to write or read or something like that. Here always have the flexibility to integrate some RESTful API. In all languages have some RESTful API like PHP, Python, or some Go or Ruby. All languages have some API to work with BigQuery. So today, this talk I will go through the 4 key points. What is the core impact, and from zero to business impact, how data can create an impact in our business, and then how you can cut off your time and cost by using BigQuery, and it's up to you can cut off your analysis time and cost up to 90% using BigQuery. The third thing is how you will use the advanced visualization tools to analyze your data, and some best practices. Let's move on. Turning data into analytics. So in these days, all SMEs and all corporations are evolving into tech solution, and all tech solution are extension is a data-driven company. So in this pandemic, already you have seen that most of the organization moved into the tech solution. So in tech solution, we can capture data and we can digitize this data for further analysis. We are getting data in raw format or some structured and some semi-structured and some are unstructured. So using the BigQuery, we have some Google Cloud tools like Google Cloud Data Prep system. So we can use these types of tools to visually analyze, cleaning and operating our data. For a small company, it's very important to have access big data tools, because for a small company, it's quite difficult to run a dedicated team for it, like how to manage your server, who is the responsible person to manage the server, and how we can scalable, is it scalable? So the primary server infrastructure setup is costly. For a small company, it's quite difficult. So that's why BigQuery is a good platform, because every month you will get 1 terabyte data free. So you can easily analyze or store your data in BigQuery. In maximum small company and mid-level company and all others organization right now using our business analysis in the legacy system. So in legacy system, we get the data source as a web and mobile platform. So when we capture the data from HTTP request or something like that, or we are getting data from some sensors like IoT devices, and it process some through the web server and have some scheduled task to process the batch, and it will process the batch processing which needs the computing engine, and then it is stored in a database, and through the database we are showing some reports analysis or chart or something like that, or more level of, if you want to analysis more advanced level analysis, you need some business analytics team or data engineer or something like that. So it's cost effective. And what is the behind the scenes of data insights? So here you can see, if you want to get the insights of business analysis from this system, we need 2 minutes to kick in the server to run the scheduled task at a particular time, or minutes or second or hour. And it will take some hours to clean the aggregate data. And as you know, in our system, you can get structured, semi-structured, or unstructured data. So you need to clean up before store or before analyzing or get the exact report what you are looking for. And it will take hours of running to process your batch. It will process batch-wise data, and then after processing without a human interaction, it will store in the database. And from database, you will get the data insights for your business. So it's the real scenario. So what is the architecture for the cloud for this? Right now, here you can see the front-end service, some front-end service where user can interact and you will get those data, and event sourcing. From event sourcing, you can capture or record every event as an object, which is managed by himself. And also we are keeping log or metrics for further analysis. And both types of integration, we are doing the pipeline for ETL engine, and ETL engine is linked to the BigQuery. So from BigQuery, Google Cloud Platform, we can analyze or further level of storage. We can use BigQuery as a warehouse as well as, so we can do the analysis for further level of any kinds of advanced analysis. So what is the data pipeline integration? When we work with data in 2016, when we get the lots of data, almost 160 million record, we face some problem. Then we came up a solution to integrate the data pipeline through the Google BigQuery and some Google services. So at Light Castle, we follow this Google suggested infrastructure pipelining architecture. Here you can see we have the ingestion system in BigQuery, cloud storage, and file upload. That means we can capture data or we can get the data from cloud storage like Google Drive. We can store data as Google Drive and we can pull it from them when we need to analysis or we need to any kind of other process. We can also do upload in any kinds of like CSV or JSON object as well. So we can also get the raw data from our BigQuery. And after that, we can do the process. So using Google Cloud Data Preparation Tool, this is the tools which is provided by Google service. And using these tools, we can visually analysis or cleaning our data for further level of operation. Here you can see the next stage after the doing some kinds of cleaning stuff, we can process the data. So here you can see the this data can move for the next stage for processing in the through the cloud data flow. In cloud data flow, we can process our data as a batch or real-time data as well. So after that, we store the data or we integrate this data as a pipeline through the BigQuery or cloud storage as well. If we redefine the data in our BigQuery or cloud storage, we can analyze the data from BigQuery, and we also integrate some kinds of third-party tools for further analysis in BigQuery, like Google DataStudio, Power BI, Tableau, Qlik, Looker, something like that. So that's came up a solution. We came up a solution followed by this infrastructure, and now it saves our human resource, cost, and time as well. Actually, how big is big? I was searching in Google. I got this information. In 2017, in YouTube's only media data is 15 plus exabyte. So for Amazon, only inventory and customer data, 42 terabytes in 2014. In Google Gmail, 18.5 plus petabytes data in 2018. And Wikipedia only English article is 10 plus terabytes in 2013. Can you imagine how the data size is? If we want to analyze or work on this type of data, how much infrastructure do we need? It's quite impossible to manage these types of stuff if you want to run a dedicated team for it. So there is a chance to improve the performance using the BigQuery. Here today I will mention 4 key points to improve the performance using BigQuery. One is partition pruning with subqueries. So this is one part. Another one is geography types. Here right now in this pandemic, we are using contact tracing, location tracking, and something like that. So we are capturing locations as a latitude, longitude. So we can do optimize these types of operation, as well as using nested fields. So, and we also can optimize our BigQuery performance into the clustering. So partitioning. Here you can see, I will show you in the live using Google BigQuery SQL window. Here you can see if we select all data, I used here a Google public dataset to just for testing purpose. Here you can see already 4.1 GB data to 30 seconds if we select all. But if we do the pruning and if we use the sub queries, we can optimize these queries, and we can also save the execution time as well as our number of processed byte. Here you can see, if we use the sub queries, I use the date as a declare as a date, and then I use those date which is max date. It could be latest date, and I used here as a date type, and then I used as a sub query and ran this query. This will took only 9.6 seconds, and it processed only first batch is processed 104 kilobyte, and then the next one is 41 megabyte. Let's see if we run this query. So I'm running this query, and here you can see it's processing. It will take up to 30 seconds to process this query, because here I select all. So we always prefer select a particular column, name column, which actually you need. So without selecting, here you can see it's processed 4.3 gigabyte within 27.9 seconds. Okay. Now let's see how we can optimize this query using sub queries. Here you can see here I declare a max date as a date type, and then I keep this data as a max date variable, and I pass this date variable as a where condition. And let's run this query. Got it? Here you can see it processed first 108 kilobyte within 7.8 seconds, and the second one it processed 41.63 megabyte. So this is the power of BigQuery, and this is by following this process or pruning the subqueries, we can optimize our execution time and we can save our cost as well. And then if we move to the next session, here you can see the geography type. As I was saying, in the contact tracing or any kinds of location tracking, always we use latitude and longitude. But every time if we want to plot or if you want to plot a location types location, then you always need to concat lat and long pass through these argument, and then you can generate the location. So it would be better if you can store as a geolocation type, which is supported by BigQuery as well. So then you do not need to every time concat those latitude and longitude. When you need this location, you just do some stuff or query as per user need. In BigQuery, we can always store data as a multi-polygon type, but using array aggregation. But we always discourage to use a multi-polygon, because as you know, the more you have polygon endpoint, the more it complex, and then it will consume your time as well as increase your cost. So try to avoid as many as possible to polygon. So you can store your latitude and longitude as a geography type, and you can store, after storing you can pass through the as a parameter, and then you can plot your geography location. So using this geography type, we can speed up our query performance up to 12%. So here you can see we used a region geometrics which has a multi-polygon. Here you can see we used the array aggregation, and if you want to use answer to get the query performance, which will take parameter as a array and it will return as a rows of record. The third thing is the using nested field. The most important part, the using nested field. Here you can see this is the query. It took 1 minute and 17 seconds, but it processed 10.1 GB data. Let's see. This is also a Google public dataset. Here you can see lots of datasets is available here. So I used this public dataset for analysis. Let's run this query. It is processing, and okay. Using nested fields like need, we basically capturing those data like in a IoT sensor. We are getting data in every minute, every second, every hour. So in a day, if we can do some aggregation without hourly to a daily. So here you can see the array aggregation to do some nested fields operation, because without having 24 hours data, we can aggregate and we can make it a single row. We can store it as a single row. Then it will automatically optimize your 24% performance. Like if you have 24 record in a day by hour, but if you use array aggregation, you can store those data as a day, like 2nd July 2020, just a single row instead of having 24 rows. So it will automatically improve your query performance, and as well as it will save your cost as well. So here you can see in this public data set, I used I queried this data set. It's have 10.1 GB data, and it took 1 minute and 17 seconds. But if we use these nested fields as a aggregation, then we can optimize these queries as well and performance as well. So we always do prefer using nested fields as many as possible, and if you have that opportunity to do some stuff to optimize your queries, you can always follow this process. And the fourth thing is we can use clustering. So if you use clustering, it will also save your execution time and performance as well. Here you can see this is without clustering. It took 0.8 seconds to process the 43 megabyte data. But after clustering, clustering is ordering your data. Like in Google Analytics, if you have multiple websites, visitors are coming and going, and you are storing those data, and you are capturing every event who is page visiting by visitors, you can store this data as a order, like you can order like website URL, time, like hour or day, something like that. So if you store this data as a ordering process and you can do the clustering, it automatically speed up your queries and it will save your cost as well. So after clustering, here you can see this to process this data, it only took 20 seconds, and here you can see it processed 576 megabyte data, which is thanks to 10x speed up. So you can optimize your queries and speed up using clustering. Here I am moving to the advanced visualization tools for data analysis. So first one was the basic, and second one is the how we can get the benefit using the BigQuery, and how we can optimize our queries performance, and how we can optimize our cost, how we can save our time as well. The third thing is the visualization for advanced analysis. To do advanced level of analysis, we can tie up or we can integrate BigQuery with any kinds of third-party services like Google DataStudio, Tableau, Power BI, Qlik, Matrix Insights, Supermetrics, PAM, and you can also interlink with Google Spreadsheet as well, and you can also interlink with Google Drive as well to store your data or import or data, something like that, for further any kinds of analysis. And you can use spreadsheet or Google Drive for your data as a data warehouse. How data format and accessing BigQuery is using right now. Here you can see the middle point is BigQuery, and we can feed in data through the BigQuery UI tool, web browser as well, and they have some APIs. And this API is supported by few most popular languages like PHP, Ruby, Python, Java, and Go as well. And if we feed in the data in BigQuery after manipulating or any kinds of data preparing, and after doing the data flow, you can use this data for the advanced level of visualization. Here you can see the average rainfall of Africa. Here you can see Uganda, Nigeria, China, Ghana, and Rwanda, Ethiopia, something like that. In BigQuery, it supports Agro, CSV, TSV, JSON, and Cloud Data Storage Export System as well. So let's move into the Data Studio, how we can access that data from BigQuery using Google Data Studio. I will just go through right now. Here you can see I interlinked with data using Google Data Studio. Let me go through this data set. From here, this is the BigQuery query window. Here you can see few options. We can store this data or result, and we can export this data or record for further analysis. I'm connecting this data set using the Google Data Studio for further analysis. Here you can see the parameter and dimension, like I want country name. Like I need a state name and some point of contact record. On the right side here, you can see lots of available charts. So here you can see this is the by default tabular format. It's showing the table format. If I just press in this section, here you can see it will give me that report. So from here you can do the cross comparison. You can move on to the data set through this. If I press the start column chart, here you can see this gives you the matrix. You can analyze your data within seconds. But just think about it. If you have 10 GB of data in your local storage or local database, how much time it will take to analyze your data? And the next thing is if you use till now, few consultant or data analysts are using the Excel or spreadsheet to analyze your data. So if the data size is bigger, the Excel will won't work. So this is the most important part in analyzing. So here you can see you can do any kinds of cross comparison analysis, as well as here you can see some start bar and also pivot table. So if you press the pivot table, it will generate the pivot table for you. So this is the power of BigQuery and Data Studio. So in Data Studio, still you have the options to export some charts and analysis your data. And we have sorry, it took a huge data. That's why it took time. So this is the stuff you can analyze your data. And the next thing is, if we move into our next take, here you can see the country name and state name, as well as here you can see the cross comparison about your country and point of contact as well. So here you have the lots of available fields. You can do the cross comparison and any kinds of analysis using this data set. So this is the most powerful data analyzing tools you can use with your BigQuery. And the few best practice we can follow. You can chunk your data or split your data as much as possible. If your data size is more than 1 terabyte, we do prefer chunk your data, and then you can do upload in your BigQuery. And split into as much as possible smaller file. It gives you two types of support or flexibility. One is it's very easier to error recovery, and the second one is the smaller is data you need, you get that a month instead of year, or extract from your timestamp. So it will also gives you the flexibility. The third thing is split tables by date. Like if you want to store your timestamp data as well, like keep, but you need the year, you can extract the year from your timestamp. So it gives you the two types of flexibility. One is it optimizes your query time, and second thing is it saves your cost, because it scans the actual required data set or data record. The less is scanned, the less you build. So that's the most important part, which saves your cost. And the third thing is denormalize or p-join use. You can use denormalize or p-join where possible, because BigQuery always work with this formula. If you can do denormalize or p-join, then you will get the best outcome. And the last thing is you can use only column that you need. Do not use select all, because it already you have seen, if you select all, it took time and scanned all the columns. But always use actual column what you are looking for. It gives you two types of benefit. One is it optimizes your query time, and it will truncate the unwanted data scan system. In the BigQuery data load, you can use 100 input jobs per table per day, and 10,000 input jobs per project per day. And the third thing is 1 GB for compressed file and 1 terabyte is for uncompressed file. You can do this importing system using your cloud storage, file upload, or using BigQuery's web API, and as well as web UI. And 10,000 files per input job it supports. And right now, 1 terabyte per input job it supports. So that's it. From my side, I'm done. And thank you. If you have any question, just put it here. I'm here to give you answer.
Harisa, I think you are on mute.
Classic mistake. Okay.
Yeah.
Okay, so I think right now there are no questions coming in from the audience. But I guess I mean there are some questions that I kind of went through as well, that came up in my head while looking through your content. So I'll ask then, if there are any questions that that the audience will raise later. We'll get to that.
Sure.
Okay, so one of the questions that kind of bugged me in the past is, okay, so in the earlier part of your presentation, you were mentioning about ensuring that your BigQuery, the cost, you want to reduce the amount of data that your BigQuery query goes through, right? So it's partly to reduce cost and partly is to reduce the amount of time to execute the query. So
Yes.
this optimization work of these BigQuery queries, it kind of requires a bit of experience from the analyst or the engineer. So how do you like okay across your company, right? How do you know that do you have a process to know that which query can be optimized further, and do you have some sort of process to go through all the queries that are written by your employees or by your team to check and work on those queries to optimize them further and to make the queries more efficient and cheaper to run? So yeah, hopefully that's the question is clear.
Yes. Thank you. Right now, we are using PHP programming language to use our web API to execute our query through the BigQuery. And right now, we are getting some. Uh, one of our staff is wondering that it can be optimized one ways. Like if you have the partition, as you know, in BigQuery partition only supports 2,000 partition at a time. But if we want some data which has the in previous or third partition, so we need, or if you want to merge those types of one or more partition, we need to do some stuff, and then again we have to aggregate those data and create new one BigQuery table. So we can optimize this system using the clustering, right? So we can store our data and queries our data using clustering. Like if you keep your data as an order, so you can do any kinds of operation using array aggregation and extract your data or unnet your data through the SQL queries. So we can do this using this process. Can. Sorry, I can't hear you. Maybe microphone is muted.
Sorry, I keep muting myself after I read the question. So all right, and then I have another question. Okay, so this is kind of a random thing. So I was promoting DataStudio like last year or something, and then like the product looks great and all, but then the question that kind of came back, and the person came back to me with a weird question where the person asked like, okay, this DataStudio is great, but do you have an on-premise version of DataStudio? Because DataStudio is an online tool, correct? But the person works in
Yes.
enterprise or government. So if such a question comes up, how do you handle it? Yeah, do you convince them that DataStudio is the solution, or do you like recommend other tools?
Uh, It depends because let me explain one thing. When we are analyzing our 160 million record using DataStudio, so we are exploring. We need some more kinds of analysis, which is still now not available in Google DataStudio. But we got those types of service in Tableau, so we moved on that later on. But it's almost 80 or 90% advanced level of analysis is covered by our Google DataStudio. So it depends on your business analysis, what types of data or analysis you are looking for. So if you do want to customize analysis or report, so obviously you do need to some manual stuff work, right? So no online tools, or it could be Tableau, it could be a Power BI, it could be Google DataStudio. No tools will give you the 100% solution. To if you need the customized solution of course you have to do some your own stuff. So at this moment, I think from our organization till as of date, we are using Google BigQuery with your 3 services. One is Google DataStudio, one is Google BigQuery as a data warehouse, and the third thing is data preparation tool, which is Google Cloud Data Preparation Tool, to visually explore and cleaning some structured, unstructured data, and then we can feed in data into our Google data flow, and then it will goes to the our data warehouse. And if we because as of know as knew that Google in BigQuery we can use to raw data as well, but if you want to analyze this, it's quite difficult to work with raw data, so we need some precise data set. And then after cleaning up the data set, we are again storing in BigQuery, and then you can tie up this BigQuery data with Tableau, Power BI, Google Data Studio, and whatever you want. But if you need some customized analysis, you can do download your data set from Google BigQuery, and it always gives you the flexibility. And after downloading, you can do your own analysis as well.
Okay, so I guess like everything kind of depends. Like that's the main
Yeah,
takeaway
exactly.
here, right? Everything really depends on your business use case, and then based on that, like your site, you will like basically recommend like certain tools for them, right? All right,
Yes.
so I guess that's all the questions I have. Wayan, you got any questions from your side?
I do have some, but I think because we are running a bit short on time.
Oh yeah, true.
So, okay, maybe we can, if there's more questions, if you guys have more questions, we can put them in the chat as well. We can also discuss about them in a bit. But yeah, so Horizon, do you have anything else to add?
Oh, so like what Wayan said, if anyone in the audience have any more questions, put in the chat. Russell will be around to to answer those questions, like as they go by. So, all right. So I guess with that, let's proceed to our next speaker. But for now, Russell, see ya.
Yeah.
Thank you.
Thank you. Bye.
Thanks for the talk.
Yeah, thanks for the talk.
Thank you.
All right. So with that, let's proceed on to the first time in this whole webinar series, our second speaker for the night. So we have Daniel Poon. So let me invite him on stage. Hello, Daniel.
Hey, hi everyone.
Yeah,
Thanks
so
for the presentation, and thanks Horizon and Nguyen for hosting this.
all right. So both myself and William will step off stage, and then we'll leave the stage all to you. So do you have
Share screen.
your do you want to share your screen?
Yes. All right. Let me share my screen.
All right.
All right. Great.
Okay.
So okay.
All right. So we'll step off. Good luck.
Okay. All right. Thanks everyone. The topic I'm going to talk about is actually a very specific topic, but it's a new it's a relatively new feature that I found very useful and very interesting. So it's self-explanatory. You should so now you are able to access Cloud SQL as a BigQuery data source, and I'll just go through a bit of slides, but most of it will be in a hands-on demo. Okay, so just a bit introduction. My name is Daniel. I'm a lead engineer at Vigo, mainly looking after the DevOps and infrastructure components. So at Vigo, we have been using BigQuery for about 4 years, 4 or 5 years, and we would like to think that we are always very excited whenever new features for BigQuery comes up. Anything that helps with the processes, anything that helps with the data people or the developers when it comes to productivity. So some of my background, I was previously in the data and backend teams. So at least some of what I say about BigQuery might have some credibility. Okay, so I'm just going to be upfront. Most of our stack is on AWS, but our data stack is on GCP. So one of the main reasons why the data stack is specifically on GCP is because of BigQuery. Simply put, the ease of use and the power that that you can get with BigQuery when it comes to crunching huge amounts of numbers, and when it comes to dealing with terabytes of data, is something that was a huge selling point for keeping some of our part of our stack on GCP. And yeah, so regardless of whatever the rest of our production infrastructure is on, I'm still a huge fan of BigQuery, and whenever there's new developments, I usually try to keep up with it. So speaking of new developments, this particular feature that I'm going to be talking about today, which is the Cloud SQL Federated Queries, was released on May 20th, 2020. I'm not sure whether Harizwan has talked about this in previous sessions as a new feature, but today we're just going to be diving deep into it. And it happened to coincide with the birthday of BigQuery. So this is a pretty awesome birthday gift. So all right, what exactly is Cloud SQL Federated Queries? So this is taken directly from the documentation. And as you can see, the focus would be on the bolded lines. It enables BigQuery to query data residing in Cloud SQL in real time without copying or moving data. So previously, one of the huge challenges is that you would like to merge these different data sources. And a very common pattern is that BigQuery would be storing logs and accumulating as much data as you need. But when it comes to an application database, BigQuery is just simply not made for that purpose. So that's where Cloud SQL comes in. So for example, if you're running a Rails app, you're running a Java app, you'll be interfacing with a MySQL or Postgres database in Cloud SQL. So there are some cases where you would like to marry these two data sources. And this is very similar to the example that I'm going to be talking about. So it's kind of a walkthrough for the documentation. And I guess like I can show some pitfalls and some things to take note of, but generally it works out of the box. So I'm just going to be doing a very quick demo just to show what kind of features we can do with this product. So okay, the premise for the demo is that we have user data in Cloud SQL. So it's to simulate an application database. And the visit logs are in BigQuery. So we assume that it's somehow extracted from the application servers and sent over into GCS. And we would like to join both data sets for analytics and CRM purposes, where, for example, you need to be able to find out maybe people who have visited your site a lot and send out an email blast or something. So when it comes to the technical setup for this demo, I'm running a Cloud SQL instance, running MySQL 5.7 in Asia Southeast 1. And there's a database test DB and users table within that DB. And the BigQuery dataset is also in Asia Southeast 1. And the dataset name is temp, and the table name is visits. So do take note that there's a reason why both of them have to be in the same region, and I'll just dive into that later. So all right, let's take a look at the demo. So ultimately, we should be able to do something like this. So ignore the syntax for now, but just note that this is from Cloud SQL, and this is from the visits table in this DB, in BigQuery. So let's just take a look at the data. So this is running on Cloud SQL, and it's in the test DB for the users table. So this is an example of the data which is inside. And all that it's doing is just running both on ID, and after that, just grouping by the user email to be able to find out how many visits they have gone. So by running this, we can see that we are able to find the respective visits for everyone. So in this case, you see that this reflects against the raw data. So there's 1 for user ID 1, 2 for user ID 2, and 3 for user ID 3. Which, so basically we have the correct data. And let me just show you what happens if I add someone new in. So now we have added a new user. And if I run it again, you can see that it's directly reflected here. So what this means is that there's no kind of replication lag. It actually reads directly from the table. So even though it doesn't show up here, but it's basically getting data directly from Cloud SQL. So this is where the original premise comes in, where you are able to find your, sorry, let me try to go back. Yes. So you're able to query for data residing in Cloud SQL in real time without copying or moving data. So this is extremely powerful. What we used to do previously was to be able to query everything on BigQuery, we needed to dump our data out from Cloud SQL and basically materialize it in a BigQuery table. But this allows you to be able to query pretty much directly from the Cloud SQL connection. So okay, let's break it down. As you see, this has an external query function. And the first argument is external connection, which can be found here. And this is the actual query that's going to be running on BigQuery. So this is pretty nifty, because if, let's say, I enter something wrongly, even before I run a query, it's able to tell that this table does not exist within that DB. So that's a really nice feature, because I rely fairly heavily on this validation to tell me whether I'm doing things wrong. So right, let's take a look at the external connection. In this case, I just set up one from scratch. All right, so the first thing you will do is you need to add data, an external data source. So over here, you'll see there's different kinds of connection types, one for MySQL and one for Postgres. And since we are running a MySQL instance, we will just select this connection type. And the connection ID, let's just go with MySQL, what we did previously. All right. So this is a very important caveat. This connection has to be in the same location as your instance. So in this case, it's in Asia Southeast 1. So it just will not work if you try to create a connection in a different location. So for example, if I create it in the US, it's not going to work. And so I have to select in Singapore. So friendly name, let's just go with MySQL. Okay, so the cloud instance ID is going to be this one. So do take note that in this case, I have the public IP address, but I have nothing else which is open to the world. So these are all kind of internal connections. And locally, when I need to access it, I am accessing it through the cloud proxy. So okay, let's just go back. So as you notice, we're not putting in any IP addresses or any DNS names. We're just putting in the Cloud SQL instance ID. And one other thing to note is that each connection is linked to a database name. So a database name in this case is testDB. For example, if you need to use multiple databases from the same instance, you have to create separate connections for them. Okay. Okay, and as you can see, this connection is created. If I click Query Connection, so the initial one that they do by default is select star from information schema tables. So as you can see, the connection works, and we are actually able to query from this. Once again, we query the table that we would like. So okay, creating the external connections is basically as simple as that. So one more thing that I would like to take note of is that the data set matters as well. So there's 3 things that need to be in sync when it comes to the region. So one of them is that your instance, you need to take note of the location. The second thing, your external connection needs to be created in the same region. And the third thing is that your data set needs to be in the same location. So what happens if, for example, I created something else in a different region, in the US region? So, okay. So instead of joining with temp visits, I'm going to try to join with data in a different region. Immediately, it would show that this is not found. Firstly, because the processing location is automatically set, but you should see a more descriptive error. Change this. So, all right, you will not be able to join data across different locations. So that's the same thing as well. If let's say you have a data set in the US and one in Singapore, even if they are materialized tables in BigQuery, you will not be able to join data across both of them. So the same goes with the connection. So yeah, that's some of the caveats when it comes to this. But I think when it comes to this, even if let's say maybe historically all your data is in the US region, and maybe you created a Cloud SQL instance in Singapore because maybe it's closer to your customers. So one way that you can work with this is that you can always materialize this into a table. So let's say I would like to get this into test DB users. You can always make a query that writes this into a data set. So one thing is that you will not be able to query this or write this into a different region. This was initially what we faced as well. But when you query for this, there's an error because you cannot read and write in different locations. So the best thing you can do is that you can query it and write it into the same data set. And then after that, you can copy a table. So it's kind of a bit of a roundabout way. Yes. Oh, wait, sorry. Yes, sorry. I got it wrong. You cannot do this. You have to copy the entire data set into a different region. Just copy. So that's the tricky bit. It's because, firstly, it uses a different API, which is a Google BigQuery data transfer. And you should see it in the transfers. So sorry, I went off script and tried to demonstrate something, and with a live demo, things always go wrong. But basically, there are ways to get around this. One of which is to materialize a table, and after that, copy it to a different data set. And that's kind of a roundabout way, but it seems to be the only way to deal with it now. So right, that was a very quick demonstration for a very quick feature. So one thing to know is that even though it looks really simple, I feel that it has so much potential. And if you would like to try to do this on other cloud providers, it is nowhere as easy as doing it with the BigQuery connection. And I've really come to appreciate how simple it is to connect different elements in the Google ecosystem. And I think this is just the next evolution when it comes to being able to join all your different data sources. So, all right, that's all I have for today. And thanks. If there's any questions, please ping me.
All right. So so far right now, there's no questions coming from the audience. So I guess it falls back to us. And I do have questions as well, as with all talks.
Yes.
So so hope you're prepared for that. But yeah, so one of the questions that I was like kind of wondering just now when you were doing your demo, so I saw that you do this external query within this BigQuery query syntax, correct?
Yes.
So it seems like the query that you need to pass it in is just plain old string.
Mm-hmm.
So let's say if you have a really, really complex query that do joins across so many tables, right? How do you validate that? Because it's just going to be a string, right? So like, do you have to keep running it against the actual MySQL database?
So
Like
ideally,
how do you validate that?
Yeah. So ideally, this should be the last step. So after you have done all your joins, you have done all your different queries on the application database, then you would just drop it in here. So I'm not sure about templating. That's a very interesting thought. Maybe you can pass in as a query parameter, maybe, if you're using the BigQuery client or Python or something. So these support templating variables. And I'm not sure whether you go through the whole hell of escaping codes or escaping different things. But yeah, it's worth a try. If you would like to break it up, even though it's all inside one block now, when you're doing the joins, you can use the with block so that you can declare it as something else. Then after that, refer to it inside the main query. If you would like to break it up a bit.
Okay. Yeah, I mean, like, yeah, because when I saw that bit, that like, it's kind of weird where you just throw the whole chunk there. It's like just hopefully no one screws up with the table column structure for the next few months.
Yes. I'm not sure whether validation would catch some of these things because they kind of need to run the query before you can find out whether columns exist or not, right? On the SQL database. So unless they have some very advanced parser where they're able to pick up these things, it's going to be very difficult. But I'm sure they do store some kind of metadata about the table. Because, for example, even for the metadata on the database, if let's say you put in an incorrect table, I don't think it's querying ad hoc when it comes to being able to detect this just for validation. So maybe they query this ahead of time. And I mean, I can't speculate how they're doing it under the hood, but if it were up to me, that would be how I do it. Instead of running it every time I change the query, I would just call it once, maybe, and with a short DTL. By the way, we're kind of digressing. I think one way to break it up is that one way that we used to do it, since we integrate with BigQuery programmatically, right? So mainly the data team would use Python. One way that you can break up your queries is that you can use some kind of templating. Maybe you have common things, or maybe you realize that you have certain things to loop over. So the data team had some success with Ginger templating for SQL queries. It's not, yeah. You should see the amount of, or like the lines of code if you do not do some templating, but it helps a bit with the maintainability. And this was back when there wasn't standard SQL. So with legacy SQL, you don't have with blocks. You cannot reuse certain predefined things. And the only way is to abstract this outside the platform itself, which is using some templating tools. So maybe that could be a solution.
Possible. Okay. And one more question from me. So, okay. So just now you were demonstrating on how kind of, okay, it's not really, okay, it's kind of straightforward on how you can connect BigQuery to MySQL, just like click all the boxes and everything. So I assume that the connection is actually pretty straightforward, pretty easy to set up, right? So, yes. Okay, so assume a scenario where this SQL database is a production database with massive amount of load, right?
Yes.
And like if you run a BigQuery and then you put some complex query, it will produce more load onto it, right?
Yes.
So is there any way to stop people from like creating all these weird connections in a haphazard manner and like running all kinds of weird queries that will trash the database? Like, is there any protection on the MySQL level around the Cloud SQL to prevent such scenarios?
So what I can think of is that firstly, if you would be running very heavy reads, you should not be running on a master. You should be running it on the right replica of your Cloud SQL database. But even if that's at risk, so one way is that I did not go through all the permissions issue because, it's my project. I have administrator access. But when it comes to Google Cloud SQL, actually it's on my slides. Let me see. All right. On the document itself, once again, always the most important thing to note is what kind of permissions you need. So only a BigQuery admin can create a connection resource on BigQuery. And so this is one way to get around it, because you should be assigning your users proper connections. And sorry, am I still sharing my screen? No, right?
Yeah, no. Yeah, we stopped sharing.
Okay. Yes. So one way around this is that we have to assign proper administration permissions to the users. But for example, once the connection is created, I'm not sure whether it can be granular enough where the IAM can block people from using an external connection, because I think there isn't any kind of IAM permissions attached to that connection. So I guess you just gotta deal with some broad strokes where you create safe connections to write replicas. Read replicas, and hopefully people don't crash your servers. I guess it's the same thing as well, because if you're an application developer and you write a very inefficient query, it's going to be against a production database anyway. So I mean, I treat data people and developers as equal. They have the same responsibilities of not trashing production servers, and to be mindful whenever they use any kind of resources.
All right, so I guess that's all the question I have. Wei Yan, you got any questions?
I don't really have any questions to add as well.
Yeah, and looks like the audience is pretty quiet today. So for anyone that's watching, right? So if you have any questions, you can just add it to the comment section on YouTube. So this video will be on the channel like by tomorrow max. So tomorrow will be I guess 3rd July in Singapore. So yeah, thanks for the talk, Daniel. So hope to talk to you next time. And then maybe we can ask you more advice about BigQuery stuff.
Yes, sure. Anytime.
Yeah.
All right. Thanks for having me.
Right. See ya.
Thank you. See you.
All right.
So going back to our, before we end off today, just to remind you guys that Cloud Next is Cloud Next Online. It's coming June 14th. We mentioned it just now as well. The link over here, cloudwithgoogle.com/next/SF. So sign up for it if you have not yet done so. 9 weeks worth of programs, very exciting stuff going on there. So hope to see you guys there. And yeah, so this is the end of webinar 6. Overall, webinar 7, Untold Story of a Code Mining Software. Well, look out for this in the coming weeks, 2 weeks from now. And with that, one of the last few things, if you are interested, if you have been, if you're looking at contributing to our community, or towards GTG Singapore as well, not only if you are a cloud-based developer, DevOps engineer using GCP, if you're an Android engineer, if you're a web developer, you're looking at sharing your knowledge with the community, we always want to hear from you guys. You can go to this link over here, bit.ly/GDG-SGCFP. So submit your ideas or your sharings over there, and we'll look into getting in touch with you as soon as possible. And yeah, definitely, first time speakers welcome, or even if you have been speaking for some time, anybody is welcome in terms of submitting your ideas over here. And yeah, our various social media links. If you have not yet joined our Facebook page, we have our Facebook page, facebook.com/groups GDG Cloud Singapore. We share a lot of articles, nice articles we find, or interesting videos that we see online. Usually we share within those pages and sort of share the knowledge of things happening in regards to GCP. And we also have our Slack channel as well. You can join the Slack channel. And yeah, last but not least, the most important part, our meetup page. Sign up for our meetup page. So because most of our events, like this one over here, usually we're posted on our meetup page. So to keep updated with all our events, you can actually go to the page. Yeah, just sign up for the subscribe to our page over there. And yeah, last but not least, if you like this webinar that we did today, like, share, subscribe, all this good stuff. If you're on Facebook, today Facebook is a little bit quiet. Sorry, not Facebook. If you're on YouTube, YouTube is a little bit quiet today. But yeah, if you liked our stream, just give us a like, share, subscribe, all those good stuff. If you're on Facebook, give us a like. And yeah, we'll see you guys next time for webinar number 7, 2 weeks from now. See you guys. Bye-bye.